Becoming an electrician presents several advantages. Firstly, there is high demand and job stability. Electricians are needed due to infrastructure growth and the constant requirement for electrical services. Secondly, financial rewards can be significant. Skilled electricians can earn substantially above minimum wage. Electricians also enjoy flexibility, with opportunities to work independently or for established companies, which offers a variety of work schedules and locations. There's also a sense of job satisfaction. Electricians often feel a sense of accomplishment when they complete projects and see their work contributing to functional buildings. However, it is important to consider the cons of this profession. The training period typically involves 4 years of apprenticeship, during which pay can be relatively low. The work can be physically demanding. Electricians often operate in tight or awkward spaces and may experience strains, cuts, and bruises. Safety risks are also a factor, as electricians work with live electrical systems which can lead to shocks and falls. Finally, long-term health concerns should be considered. Repetitive bending, lifting, and kneeling can contribute to back injuries over time. Now let's address some specific concerns. Regarding electrical shocks, the risk can be minimized through the use of proper safety gear and thorough training. With respect to falls, adhering to safety protocols and utilizing appropriate ladders and equipment can significantly reduce the likelihood of accidents. As for back injuries, maintaining correct posture and employing ergonomic tools can aid in preventing back problems. In conclusion, a career as an electrician can be a promising option, offering solid job prospects and the potential for good financial compensation. However, it's essential to understand the physical demands and potential safety risks involved. By taking the necessary precautions and undergoing proper training, one can address these concerns and pursue a rewarding career in the electrical field. Electricians work with electrical systems, which involve several fundamental concepts. Electrical current is the flow of electric charge measured in amps. It is the rate at which charge passes through a conductor. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It drives the current through the circuit. Resistance, measured in ohms, opposes the flow of current. It is the property of a material that resists the flow of electric charge. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage equals current times resistance, or volts equals amps times ohms. Power, measured in watts, is the rate at which electrical energy is transferred. It is calculated by multiplying voltage and current, or watts equals volts times amps. There are 2 main types of electrical circuits: series circuits and parallel circuits. In a series circuit, components are connected end to end, so the current is the same through all components. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, so the voltage is the same across all components. The total resistance in a parallel circuit is calculated using the reciprocal of the sum of the reciprocals of the individual resistances. Electrical wiring typically involves several types of conductors. Copper is a common conductor due to its high conductivity and ductility. Aluminum is another conductor, often used in high-voltage transmission lines due to its lighter weight. Wires are typically insulated to prevent electrical shock and short circuits. Common insulation materials include plastic, rubber, and PVC. Electrical codes and standards are essential for ensuring safety and proper installation. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides guidelines for wiring methods, overcurrent protection, grounding, and other safety aspects. Electrical safety is paramount when working with electrical systems. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental energization of circuits. Be aware of potential hazards such as exposed wires, damaged insulation, and wet environments. Grounding is an important safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. Grounding systems typically involve grounding electrodes, grounding conductors, and equipment grounding conductors. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from excessive current. Circuit breakers are resettable devices that trip when the current exceeds a certain level. Fuses are one-time devices that melt and break the circuit when the current exceeds a certain level. Wiring methods refer to the techniques and materials used to install electrical wiring. Common wiring methods include conduit, cable, and surface racewire. Conduit is a rigid or flexible metal or plastic tubing used to protect and route electrical wires. Cable consists of two or more insulated conductors enclosed in a sheath. Surface raceway is a metal or plastic channel used to route wires along walls or ceilings. Electrical boxes are used to enclose wiring connections and protect them from damage. Common types of electrical boxes include junction boxes, outlet boxes, and switch boxes. Wiring connections must be made properly to ensure reliable and safe operation. Common wiring connections include wire nuts, terminals, and splices. Wire nuts are used to connect two or more wires together by twisting them together and then screwing on the wire nut. Terminals are used to connect wires to devices such as switches, receptacles, and light fixtures. Splices are used to join two or more wires together by soldering, crimping, or using a mechanical connector. Electrical drawings and diagrams are used to represent electrical systems and components. Common types of electrical drawings include single-line diagrams, wiring diagrams, and schematic diagrams. Single-line diagrams show the main components of an electrical system and their connections. Wiring diagrams show the physical connections between components. Schematic diagrams show the electrical connections between components using symbols. Electrical testing and troubleshooting are important for identifying and resolving electrical problems. Common electrical testing tools include multimeters, voltage testers, and circuit tracers. Multimeters are used to measure voltage, current, and resistance. Voltage testers are used to detect the presence of voltage. Circuit tracers are used to identify the path of a circuit. When troubleshooting electrical problems, it is important to follow a systematic approach. Start by identifying the symptoms of the problem. Then gather information about the system and its components. Next, use testing tools to diagnose the problem. Finally, repair the problem and verify that it is resolved. Here are some additional topics related to electrical work. Motors are used to convert electrical energy into mechanical energy. There are many different types of motors, including AC motors, DC motors, and universal motors. Transformers are used to step up or step down voltage levels. They consist of two or more coils of wire wound around a common core. Lighting systems are used to provide illumination. There are many different types of lighting systems, including incandescent lighting, fluorescent lighting, and LED lighting. Control systems are used to automate and control electrical equipment. Common types of control systems include relays, timers, and programmable logic controllers, or PLCs. Renewable energy systems, such as solar and wind power, are becoming increasingly popular. These systems generate electricity from renewable sources. Electric vehicle charging stations are becoming more common as electric vehicles gain popularity. These stations provide electricity for charging electric vehicle batteries. Smart home technology is integrating electrical systems with automation and control features. This includes lighting control, appliance control, and energy management. The electrical field is constantly evolving with new technologies and techniques. It is important for electricians to stay up to date on the latest advancements in the field. This can be achieved through continuing education courses, professional organizations, and industry publications. Some examples of specific tasks an electrician might perform include installing electrical wiring in new construction, troubleshooting electrical problems in existing buildings, repairing or replacing electrical equipment, installing lighting fixtures, installing and maintaining electrical control systems, and working on renewable energy systems. When working with electrical systems, it is important to understand the different types of electrical circuits. A circuit is a complete path for electrical current to flow. It consists of a source of electrical energy, a load, and conductors to connect the source and load. A closed circuit is a complete path for current to flow. An open circuit is a broken path that prevents current from flowing. A short circuit is an unintended path for current to flow, typically caused by a fault in the insulation. It is also important to understand the different types of electrical loads. A resistive load is a load that converts electrical energy into heat, such as a light bulb or a heater. An inductive load is a load that stores energy in a magnetic field, such as a motor or a transformer. A capacitive load is a load that stores energy in an electric field, such as a capacitor. When working with electrical systems, it is important to understand the different types of electrical diagrams. A wiring diagram shows the physical connections between components. A schematic diagram shows the electrical connections between components using symbols. A single line diagram shows the main components of an electrical system and their connections. When working with electrical systems, it is important to understand the different types of electrical codes and standards. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides guidelines for wiring methods, overcurrent protection, grounding, and other safety aspects. The Canadian Electrical Code, or SEC, is the standard for electrical installations in Canada. The Australian New Zealand Wiring Rules, or ASNS 3000, is the standard for electrical installations in Australia and New Zealand. When working with electrical systems, it is important to understand the different types of electrical safety equipment. Insulated gloves are used to protect hands from electrical shock. Safety glasses are used to protect eyes from flying debris and electrical arcs. Lockout-tagout devices are used to prevent accidental energization of circuits. Voltage testers are used to detect the presence of voltage. Circuit tracers are used to identify the path of a circuit. When working with electrical systems, it is important to follow safe work practices. Always energize circuits before working on them. Use appropriate personal protective equipment. Follow lockout-tagout procedures. Be aware of potential hazards. Work in a well-lit and ventilated area. Keep your work area clean and organized. Do not work alone. If you are unsure about something, ask for help. Remember that electricity can be dangerous, so it is important to take precautions to protect yourself and others. In Australia, electricians need to be licensed. The licensing requirements vary from state to state, but typically involve completing an apprenticeship and passing an exam. Once licensed, electricians are required to continue their education to stay up to date on the latest codes and technologies. There are also different types of electrical licenses in Australia, such as electrician, electrical contractor, and electrical inspector. Each license has different requirements and allows the holder to perform different types of work. The electrical industry in Australia is regulated by various government agencies and industry bodies. These organizations set standards for electrical work and ensure that electricians are properly trained and licensed. Some of the key organizations include the Electrical Regulatory Authorities Council, or ERAC, and the National Electrical and Communications Association, or NECA. The demand for electricians in Australia is expected to remain strong in the coming years, due to factors such as population growth, infrastructure development, and the increasing use of electrical devices. This means that there will be plenty of job opportunities for qualified electricians. In addition to traditional electrical work, there are also opportunities for electricians in specialized areas such as renewable energy, automation, and communications. These areas require additional training and expertise, but can offer higher pay and more challenging work. The salary for electricians in Australia varies depending on experience, location, and type of work. However, electricians typically earn a good salary and have good benefits. According to recent data, the average salary for electricians in Australia is around 70,000 to 90,000 Australian dollars per year. Electricians also have the opportunity to earn extra money through overtime and on-call work. Many electricians in Australia choose to start their own businesses. This can be a rewarding experience, but it also requires a lot of hard work and dedication. Electricians who start their own businesses need to be knowledgeable about business management, marketing, and customer service. They also need to be able to manage their finances and comply with all relevant regulations. The electrical industry in Australia is constantly evolving, so it is important for electricians to stay up to date on the latest trends and technologies. This can be achieved through continuing education courses, industry conferences, and online resources. Some of the key trends in the electrical industry include the increasing use of renewable energy, the growth of smart home technology, and the development of new electrical materials and equipment. Electricians who are able to adapt to these changes will be in high demand in the future.